We're going to talk about acids and bases, their definitions, and how to identify them in a chemical equation. Usually, acids contain hydrogen atoms and bases contain hydroxide. However, that's not always the case. So we have three different theories to help us identify which ones are acids and which ones are bases. An Arrhenius acid contains a hydrogen atom and dissolves in water to form H+. An Arrhenius base contains hydroxide and dissolves in water to form OH-. HCl yields H+ plus Cl-. HCl contains hydrogen and when it's dissolved in water forms H+. NaOH yields Na plus OH-. NaOH contains hydroxide and when it's dissolved in water forms OH-. So Arrhenius acids and bases deal with H pluses and OH-. A Brønsted-Lowry acid is a proton donor and a proton is just H+. Brønsted-Lowry base is a proton acceptor. HCl plus H2O yields H3O plus Cl-. So HCl starts off with one hydrogen and yields something with no hydrogen. So it loses one of its protons. So HCl is a Brønsted-Lowry acid. NH3 plus H2O yields NH4 plus OH-. NH3 starts off with 3 protons, but yields something with 4 protons. So NH3 accepted a proton. So NH3 is considered a base, a Brønsted-Lowry base. So Brønsted-Lowry acids and bases, you're looking for proton donors and proton acceptors. A Lewis acid is an electron pair acceptor. A Lewis base is an electron pair donor. With Lewis acids and bases, this can be hard to see, so the best thing you want to do is draw out your Lewis structures. F- plus BF3 yields BF4-. In the Lewis structure, BF3 does not obey the octet rule because boron is an exception. And F- has a lone pair of electrons. So these lone pairs will bond with boron. Since F- is going to give up a lone pair, this is considered a Lewis base. And BF3 is accepting the electrons, so this is called a Lewis acid. Let's take a look at an example. Let's identify the acid, the base, the conjugate acid, and the conjugate base. HA plus B yields A minus plus HB plus. We're going to take a look at HA, and it starts off with 1 proton and then ends up with no protons. So something that gives up a proton is called an acid, and the result is called the conjugate base. B has no protons but ends up with 1 proton on the product side. So B accepts a proton. This is called a base, and the result is called a conjugate acid. Since this is an equilibrium, we can examine this in the reverse. Let's take a look at A-. It starts off as A-, but in the reverse, it ends up as HA. So this accepted a proton. Anything that accepts a proton is called a base, but because it's on the product side, we call it conjugate base. HB plus starts off with 1 hydrogen, but ends up with no hydrogens. Something that gives up a hydrogen is called an acid, but because this is on the product side, we call this conjugate acid. Let's take a look at the next example. HNO2 plus H2O yields NO2 minus plus H3O plus. HNO2 starts off with 1 proton, but then ends up with no protons. So something that donates a proton is called an acid, and the result is called the conjugate base. H2O has 2 protons, but ends up with having 3. So now anything that accepts a proton is called a base, and the result is called a conjugate acid. We can examine this in the reverse. NO2 minus has no protons, and in the reverse, it has 1 proton. Something that accepts a hydrogen is called a base, but because this is on the product side, we say conjugate base. H3O plus has 3 protons, and in the reverse only has 2. So it gave up a proton. This is called an acid, but it's on the product side, so we call it conjugate acid. HSO4 minus plus NH3 yields SO4 minus plus NH4 plus. HSO4 has 1 proton, and on the product side it has no protons. So something that gives up a proton is called acid. And the result is called conjugate base. NH3 has 3 protons, and in the product side, it has 4 protons. So something that accepts a proton is called base, and the result is called conjugate acid. And let's examine the reverse. SO4 minus has no protons, and on the reactant side, it has 1 proton. Something that accepts a proton is a base, and because this is on the product side, we call it conjugate base. NH4 plus has 4 protons. In the reverse, it has 3 protons. Something that donates a proton is called an acid, and because this is on the product side, we call it conjugate acid. Let's look at a different way of doing this. Identify the conjugate acid of HS minus. So they want you to imagine that HS minus is a base, and bases accept a proton. So H plus and HS minus. We're going to crisscross the charges, and we're going to get H2S. So HS minus is the base, the conjugate acid is H2S. Identify the conjugate base of HSO4 minus. So that means imagine HSO4 minus as an acid. What do acids do? They give up a proton. They give up an H plus. So if I give up an H plus, it becomes SO4 minus. Now the next ones are kind of tricky because Y and Z are not real elements. Identify the conjugate acid of H2Y minus. That means imagine H2Y minus as a base. Bases accept a proton. So I'm going to crisscross these charges, and I'm going to get H3Y. Identify the conjugate base of H2Z minus. So H2Z minus, imagine it to be an acid. Acids donate a proton. They give up an H plus. So the conjugate base would be HZ2 minus. Good luck and keep practicing.